Okay, how about another example with a 30, 60, 90? And I've made this image smaller, right? This triangle is similar to this triangle because the angles are congruent, right? I've just dilated it to be a little bit smaller. But let's take one that might be a little bit more complicated. Say this is 5. Okay, so let's say I wanted to find these other two side lengths in this right triangle. Okay, well, I don't know this side, I don't know this side, I know this side is 5. But again, it's going to be my suggestion, and this is the way that I've always taught this, is that when you have a 30, 60, 90 triangle, immediately label the sides according to the ratio that you already know, right? So you should know that in a 30, 60, 90 triangle, the short side, we're going to label that as X because the other two sides are based on that, right? And then the hypotenuse is twice as long, and the long leg is radical 3 times whatever this is. And if you do that, knowing any one of these sides is going to give you an equation that you can solve, right? Finding X is the key here because these other two sides are based on X, right? So if even if you wanted to know this side, knowing this side is gonna be determined by knowing what X is. And if I say, okay, well, I don't know what X is, but I know that whatever it is times radical 3 is equal to 5, this gives me an equation that I can solve for that unknown value. So it gets a little weird, it gets a little messy. I'd have to divide by radical 3 here, right? And then I'd have X equals 5 over radical 3. And that's typically not acceptable. So we'd have to multiply that by radical 3 to rationalize the denominator. We get 5 radical 3 over 3. And that's our value of X. Okay. So up here, we know that this is 5 radical 3 over 3 now. And that's the value of X. So the value of this side is 2 times 5 radical 3 over 3, right? Substituting this in for the value of X. And I can put a 1 here if you want to make this a little more consistent. These integers that aren't under the radical can get multiplied together. And then the radical stays the same and this denominator stays the same. So we get these values. It's a little weird when that long leg is not, or I should say when that long leg is an integer. These almost always end up being a little bit weird looking with those radicals, but we get what we get.